In Chapter 11, we will be spending all of our time, pretty much most of our time, solving quadratic equations. But we're going to have to look at solving quadratic equations that can't be factored. Now, I've been nice to you up to this point where everything I've given you has been nice and pretty and factorable. But what if they don't factor? Now, let's start off with something very nice and basic. If I give you x squared equals 16, this is quadratic, and we know how to solve quadratic equations. The way we learned to solve these before was that we get everything to one side of the equation so that 0 is on the other side. Then we use the zero factor theorem. And the zero factor theorem says you have it equal to 0, you factor, and you set each non-constant factor equal to 0. X squared minus 16 is the difference of squares, so x plus 4 times x minus 4, and we come up with the solutions x equals negative 4, or what? X equals positive 4. We get two solutions. We expect two solutions because this was quadratic. The exponent gives you a clue as to how many solutions you can have. So everything worked out great here. Well, what if I have the example x squared equals 18? Now if I try to solve this the same way, I would have x squared minus 18 equals 0. Unfortunately for us, this guy right here is prime, which means this guy does not factor using integer values. Well, there's got to be a way to solve this, and that's where this guy comes in. The title of this section is about the square root property. There's another part of this called completing the square, and we'll get to that later. But here's what the square root property says. Okay, here is the square root property. The square root property says this. It says if x squared is equal to a. Okay, keep in mind here that a is going to be some constant. And, well, I guess more than just saying a constant, let's make sure that we understand this is going to be a real number. A is going to be a real number. That's what we're talking about. So if x squared equals a, then my solutions x will equal plus or minus the square root of a. Now this is something you may have suspected for a while, but we're putting it in formal writing for you. If x squared equals a, then your solutions, just x, will be plus or minus the square root of a. This symbol right here, we read this as plus or minus. Now we actually could have used that on the very first equation that we had. When I had x squared equals 16, I can apply the square root property to both sides and get my solution. So here's what it would look like. I would basically be taking the square root of that side, and it would equal the square root of the other side, but with one little catch here, and that's the plus or minus. When you are applying the square root property and you're putting the square root on both sides, you've got to have the plus or minus. That plus or minus is what will help you get your two solutions that you're supposed to have according to that exponent. So this gives me just x, and this is plus or minus the square root of 16, which is 4. And that matches up with the solutions that we already had. If you go back up here, we said that x equals negative 4 or x equals positive 4. We got that from factoring, and now we're getting it from the square root property. Now, if that's the case for that problem, could we then use this square root property to help me solve equations that don't factor? X squared equals 18, we saw it gave us a problem because it was prime. Well, what I'm going to do now, according to the square root property, now you can show the square root on both sides, or we can just go ahead and apply it directly and say that x, just like we have here, x equals plus or minus the square root of 18. So I could have put the square root over here, so the square root of x squared is equal to x, but I just went ahead and did exactly what the square root property says. If x squared equals a number, then your x is going to be plus or minus the square root of that number. Now this answer is not good enough because we know that 18 can break down. It can be simplified. 18 breaks down to be 9 times 2. And of course 9 is my perfect square, and he comes out as the 3. Now, one of the biggest mistakes that students make when we're doing these problems is where the numbers go. The plus or minus is your sign. Anything that comes out of the radical is still going to be in front of the radical, just like when we were simplifying these guys in the last chapter. So x equals a plus or minus 3 comes out, and you are left with 2 inside the square root. So these are your two solutions, plus or minus 3 square roots of 2. In the last example, the square root of 16 is 4, so plus or minus 4. Over here, the square root of 18 was 3 square roots of 2, so it's plus or minus 3 square roots of 2.